Welcome to 7.3 Multivariable Linear Systems. We're only doing partial fractions in this section. Partial fractions is taking a rational expression, such as this one, and breaking it up into a sum of two or more simpler rational expressions. So this one only has two. We will do some that have three. Here are the steps we're going to use to decompose into partial fractions, and I'll go through obviously this with some examples. We're going to factor the denominator. We will write it as a sum of a, b, and possibly c if there are three factors. We'll multiply by the common denominator just like we did when we solved. And then this is the part you'll kind of have to watch the example, but we're going to choose values of x, and we're going to really choose the excluded values because that will make the process a little bit easier so we don't have to solve a system all the time, and then we'll solve our equations and then rewrite as a sum of fractions. So once you have those written down, and then we're just going to kind of go through a couple different types of examples that you will see. The first one here is going to be 6x minus 2 over x squared minus 3x minus 10. So we will start by rewriting. We have 6x minus 2. We'll factor the denominator here into x minus 5 and x plus 2, and then we rewrite it as a sum. So we have a over, because we're trying to figure out the numerator. We know the denominator will be one of the factors x minus 5 plus b over the other denominator of x plus 2. So once again, that goes back to express as a sum of a and b and possibly c, but this only has two factors, so a and b. We're then going to multiply by that common denominator. So all of this gets multiplied by the factor x minus 5 and x plus 2. And so all of that is going to cancel, which will leave you with just 6x minus 2. The x minus 5 will cancel. This x minus 5 will cancel with this x minus 5. And so that'll leave you with a times just x plus 2 plus this x plus 2 and this x plus 2 will cancel and leave us with b times x minus 5. So now what we can do is we can choose values of x, and that goes back to step 4, choose values of x. We can choose any value of x that we want, and it will give us an equation, typically with the unknowns a and b. But what we're going to try to do is be a little bit more strategic about this, and we're going to choose values of x that are unknowns, and the reason are restrictions. And the reason we do this, so x equals 5, it will cancel out one of our variables of a and b. So if we plug in 5, we get 6 times 5 minus 2 is equal to a times 5 plus 2 plus b times 5 minus 5. So the nice thing about this is we get 0 times b, and it just cancels it out and leaves us with just the variable of a. So we have 7a, and then that's that b times 0, so we get 28 is equal to 7a divided by 7, and a is equal to 4. So we know the a value is 4. Now we need to find the b value. So we will now choose our other restriction of negative 2. And so same thing's going to occur, but when we plug in negative 2, it will now cancel the a variable because it'll be negative 2 plus 2. And then that will allow us to solve for the variable of b. So we get negative 12 minus 2 is equal to a times 0, so that's the a canceling, and then b times negative 7. So this one we get negative 14 equals negative 7b divided by negative 7, and b is equal to 2. So we have now found the a and b values. We've solved those equations, and now we're going to rewrite as a partial fraction. So the end result here, we're going to go back and rewrite the original 6x minus 2 divided by x squared minus 3x minus 10 is equal to a is 4, so that's 4 over x minus 5 plus b is 2, so 2 over x plus 2. So those two things are equivalent, and we rewrote it as a partial fraction. So now, instead of giving you kind of the exact same example, I've given you something else where you have more factors. So when we go to do this one, we have the x minus 2, but now you can factor out an x, which leaves you with x squared plus 2x plus 1, and then you can actually factor out that again, or factor that quadratic to x plus 1 times x plus 1. So we got a couple things here. We got 3 factors this time, and we also have one of them repeating. So how is that going to change kind of our approach to this? Well, let's go ahead and rewrite as our sum of a, b, and in this case, c. So it'll be x minus 2 over x cubed plus 2x squared plus x, or in factored form we could have wrote that, is equal to a over the factor of x plus b over the factor of x plus 1 plus c divided by, now since it's x plus 1 again, we're not going to write x plus 1 just one time. We have to write it that it's going to happen twice. So it's x plus 1, and then x plus 1 squared as our third factor there. And so now we just go back and continue on. We multiply by the common denominator, which was x times x plus 1 squared, or x plus 1 times x plus 1. So on the first one, all of this always is going to cancel and just leave you with the x minus 2. So it'll be x minus 2 is equal to, now only the x is going to cancel, so you're left with a times x plus 1 times x plus 1 plus b. Now the x plus 1 will cancel with one of them, but there'll still be x times x plus 1. So b times x plus 1 plus c. Now both x plus 1s are going to cancel, and that's why we need that square there. And then so c, we only have the x value. So our restrictions on this one, you have 3 factors but only 2 restrictions. X cannot equal 0 and x cannot equal negative 1. So that's how we're going to set this up. We'll start with just x cannot equal 0, and that will be the one that we actually plug in. And that will cancel 2 of our factors. It'll cancel the b and the c, because when x is 0, you can see if you put a 0 here and here, it's going to cancel everything out. So we have 0 minus 2 is equal to a times 0 plus 1 times 0 plus 1 plus b. And I'll write it this time, but you're going to see that that's going to cancel everything out. Alright, so we have negative 2 is equal to a times 1 plus b times 0 plus c times 0. Once again, those are canceling out. So it looks like we get negative 2 equals 1a, or a is equal to negative 2. So that's 1. Now what happens when we plug in the other restriction of negative 1? So let's plug in negative 1. So negative 1 minus 2 is equal to a times, now a is going to cancel because it's negative 1 plus 1, which is 0. So a will cancel. B will also cancel because there's that negative 1 plus 1 in there, which is 0. And it'll be the c value that doesn't cancel. So it looks like we get negative 3 is equal to a times 0 plus b times 0 plus c times negative 1. So negative 3 is equal to negative 1c, or negative c. So c is equal to 3. So far we found the a and we found the c, but we didn't find the b, and we don't have any more restrictions to plug in. So what do we do at this point? Well, kind of go back. Choose values of x. You can use the excluded values, but you don't have to. So let's now choose a value of x that is not excluded. Let's just go ahead and choose x equals 1. Now that we know what a and c are, we can also plug those in, and then that will help us find b. So we're going to plug in x equals 1. So we'll do 1 minus 2 is equal to, and I'll leave the a in there and I'll plug those in just a little bit. So a, this will be 1 plus 1 times 1 plus 1 plus b, if x is 1, it'll be b times 1, and then 1 plus 1, and then plus cx, so plus c times 1. And so as we go to simplify, negative 1 is equal to, now you got 1 plus 1 is 2, so 2 times 2 would be 4, so that's 4a plus 1 times 1 plus 1, so that'd be 2, so it'd be 2b, and then c times 1 is just c. But we also know a is, scroll back over here, a is negative 2, so we can now plug that in. We know, we don't know b, so we'll leave that there, but we know c is 3. So now we have everything, and we can solve for b. So we get negative 8 plus 2b plus 3. So that'd be negative 5 plus 2b. Add the 5 to the other side, so we get 4 equals 2b. Divide by 2, and we get b equals 2. So if the restrictions don't work, you're just going to have to plug in a different number and then go ahead and solve from there. So our final answer for this one, now that we know what a, b, and c are, we will now say that x minus 2 and then over the original x cubed plus 2x squared plus x is equal to, a had a value of negative 2, so that's negative 2 over x, plus b had a value of 2, so that's 2 over x plus 1, plus c had a value of 3 over x plus 1 squared. So that one's a little different, but still the same process that you go through. Example 3 is similar to the first two, so if you feel pretty good about things, I would just pause it and practice it yourself and see if you can get it. Alright, here we go. So we're going to start by factoring. So we have the 3x squared plus 2x minus 2, and we're factoring the denominator, so we factor out an x. And then we can factor one more time again. And so we have 3 factors. The difference on this one is all 3 factors give you a different restriction. So we'll be able to plug in all 3 restrictions at the end. Let's go ahead and rewrite as 3x squared plus 2x minus 2. And we're going to rewrite as a sum of a, b, and once again, c. So a will be over x, plus b is over x minus 3, plus c is over x plus 1. Go ahead and multiply by your common denominator of x times x minus 3 times x plus 1. So I multiplied everything through, canceled my common factors, and now I'm left with this. Once again, we're going to choose our restrictions. So we'll choose x equals 0, we'll choose x equals negative 1, and we'll choose x equals positive 3. So those are the values we're going to choose. We're going to plug them in and simplify. So once I plugged it in, the b and the c are going to cancel out. This will leave me with negative 2 equals a times negative 3 times positive 1. So negative 2 is equal to negative 3a. A is equal to a positive 2/3. Alright, we'll go ahead and plug in x equals negative 1 next. So after I plugged in the negative 1, I simplified and got c equals negative 1/4. And now we do it one last time with x equals 3. And so after plugging in x equals 3, I got b is equal to 31/12. So now we need to write our final answer. So as we write our final answer, I know some of you are going to say, okay, if a is 2/3, I'm going to put it up here, but we don't want a complex fraction. So instead of writing 2/3, 2 will be in the numerator, but the 3 goes to the denominator with the factor of x. So it'll be 2 over 3x plus b, which is over here 31/12, so that'll be 31 over 12 times x minus 3, and you can leave that, you don't have to distribute that back in, plus c, which is negative 1, so instead of doing a plus, I'm going to do a minus 1 over 4 times x plus 1. And you can leave it in that form. So no complex fractions with those fractions. When you get a, b, and c, just make sure you got your numerator and your denominator in the right place. and just make sure you don't write it as a complex fraction. So there's another example of multiple factors for a partial fraction.